Well, welcome to Chapter 7, and we're going to jump right into Section 2. Use the converse of the Pythagorean Theorem. Our objective is that we want to, or our essential question, let's say it that way, is how can I use the converse of the Pythagorean Theorem to determine if a triangle is a right triangle. That's what our goal is to figure out here. And you are familiar with the Pythagorean Theorem, of course. C squared equals a squared plus b squared. That is true for all right triangles, as long as you have a right angle, 90 degrees here. And you remember that across from your right angle, this is the hypotenuse. In fact, let's go ahead and label that dude as your hypotenuse and get accustomed to spelling it. I think I spelled it correctly there. I did. And so that is true for a right. If there's a right angle here, then across from that is your hypotenuse. And the hypotenuse is always the side that goes in for the C. But what if we do not know whether or not this is a right angle? But we do know the length of all three sides. Can we do this, use the Pythagorean Theorem in the converse? Remember, converse means to switch. So instead of starting with a right angle and saying that the Pythagorean Theorem is true, the converse of that is starting with the three sides and determining whether or not it is a right angle. Because sometimes it's not a right angle. Sometimes this, what should be the hypotenuse, is too small, and that's going to be an acute triangle. Or sometimes what should be the hypotenuse is too big, and that's going to create a obtuse triangle. So that's why they call this the converse. So if c squared does equal a squared plus b squared, then this longest side is just right, and it is a right angle here, and therefore it is a right triangle. But if the c squared, the c, which should be the hypotenuse, is too small, in other words, c squared is less than a squared plus b squared. So this, what should be the hypotenuse, is too small. It doesn't match up to a squared plus b squared. It's less than a squared plus b squared. So what you're doing here, here is your right triangle, and I'm sorry, a triangle, and your angle here. And if it was a right triangle, this hypotenuse would be the correct size. But when the hypotenuse is too small, then it makes, or what should be the hypotenuse is too small, then it makes this, what we were hoping to be, a right angle. It makes it smaller than a right angle, and that turns into an acute triangle. Or if the longest side is too big, it opens this thing up and it goes beyond what it should be, then it's not a right angle, it becomes an obtuse angle. And that's what we're saying here, that this longest side is too big, so therefore c squared, what we're saying is c squared is greater than a squared plus b squared, and therefore this is an obtuse angle. Again, you're pushing that angle open beyond 90 degrees because this longest side is too long, too big. Okay, and then we've talked about this before, the triangle inequality theorem. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. And specifically, we've talked about that the sum of the two smaller sides has to be greater than the longest side. And so let's apply these truths and see what we can do. Here's example number 1 from the textbook, and they're asking us, is this a right triangle? So all that we know is the length of the sides, and we want to determine whether or not it is a right triangle. So how do we do that? Well, first we have to pick out the longest side, And visually, we can see here the longest side is this one. Sometimes, though, we don't have the visuals on it. They'll just give us the numbers, like, for example, down here. And we need to plug that into a calculator and see what that number is, and see if it's larger or smaller than this one. So do not assume that the number on the far right is always the longest side. Sometimes it isn't. So when you see a square root, make sure that you simplify that using your calculator and know for sure which one of these is the longest side. But in this case, we know this is the longest side, and so if this was the hypotenuse, then this would be the C. So we plug that in for C here, and C squared, and we're asking the question, is it equal to? So that's an equal sign with a question mark on top of it. We're not sure whether or not it really is equal to A squared plus B squared. And when you calculate it out, on the left hand side it turns out to be 306. On the right hand side it's also 306. So what does that tell us? Well, of course we know 306 equals 306, but what that is telling us is that these sides do satisfy the Pythagorean theorem. And when the side lengths satisfy the Pythagorean theorem, then the measure of this angle is 90 degrees, and this is a right triangle. Here's another one, and we're looking at this as 14, 22, 26. Okay, this is my longest side, so that's going to be plugged in for my C. So 26 squared, and we're asking, does that equal 22 squared plus 14 squared? And when we do the work with our calculator, we see that on the left is 676, and on the right is 680. So those numbers obviously are not equal to each other. That tells us that this is not a right triangle. The sides do not satisfy the Pythagorean theorem. So our C squared, this 676 is smaller than 680, so our C is too small. It needs to be longer, it needs to be bigger in order to match what we would need to make it a right triangle. So when the hypotenuse is too small, then what kind of a triangle is this? It's not a right triangle, it is an acute triangle. Remember, that's what we're saying here? So if the hypotenuse is too small, therefore instead of being a right triangle, it's squished down because this longest side is not long enough. It's too small. Therefore this angle is going to be an acute angle. So in this case, all they're asking for is whether or not it is a right triangle, and we would say no, it's not a right triangle, but we can also say that it is an acute triangle. And that's what we're asking you to do here. Do I want to do any more exercises? Yeah, let's do some more of it. Let me just do a few more of these before I cut you loose. This is a quick section. So where are we at? Here it is. And let me bump it up here, make it a little bit bigger for you. So here's a few more examples in the book, and they give us three sides: 4.3, 5.2, and 6.1. And they're asking us, okay, what kind of a triangle do these three sides make? Well, remember, we first have to see whether they make a triangle. And how do we do that? We find the longest side is 6.1. And remember, the sum of the two smaller sides has to be greater than the third side. So, of course, 4.3 and 5.2 is greater than 6.1. And so, therefore, yes, this does create a triangle. But now the question is, what kind of triangle? Is it an acute, or a right, or an obtuse triangle? So we start off with, here we go, down here, C squared, and we're asking the question, does it equal A squared plus B squared? So which one do we plug in for C? Of course, the largest one, so 6.1 goes in for C, and then the other two go in for A and B. And once we calculate that, C squared is 37 and change, And on the right hand side, a squared plus b squared is 45 and change. So what should be the hypotenuse is too small. 37 is less than 45. So this, what should be the hypotenuse, is too small. So what kind of a triangle is that? So we're looking here, and where's my pen? So again, if we would start out with a right triangle, and now we're saying this length over here, this longest side is too small, so it's getting smaller, so therefore this angle is going to be an acute triangle. Remember, if the third side is too big, it's going to open this up, and it's going to be an obtuse triangle. So in this case, this is an acute triangle, is what they're saying. And that is it, my friend. You should be able to do the rest. And really, all four of these problems are essentially the same type of problem. So start out with c squared equals, and with a question mark. That's a question mark there. A squared plus b squared. Make sure you figure out which one is the longest. For me, I had to plug this into a calculator. 4 times square root of 3 is approximately 6.9. And so that is smaller than 8. So 8 is my longest side. And so the 8 is going to go in for the c squared. And then plug in the other two numbers in for a squared and b squared. And then simplify it and see what your numbers are. And if c squared is equal to a squared plus b squared, then it's going to be a right triangle. That c squared is just right. Or if c squared is too small, then it's going to be an acute triangle. Or if c squared is too big, it's going to be an obtuse triangle. But remember, before you do that, make sure that you take the two smaller sides and add them together, and that it is greater than the third side. So make sure you do that with each one of these to confirm, first of all, that it does make a triangle, and then determine what kind of triangle it is. Okay, we're done. I hope that was helpful to you, and I look forward to seeing you in class, and may the Lord bless you.